Hi and welcome! Are you randomly clicking on layout group settings, hoping to magically find the one setting you need? By how often I have been asked to cover the UI layout system, you are far from alone. And I know the feeling, I've been there. And I'm sure you've seen the runtime and wonder why the ever-loving ducklings you should stick around for that long while other tutorials take a fraction of the time? Because I'm certain that after going through this video, you won't randomly click around on layout components anymore. You will know which components to use, where and why to use them, as well as which settings to tick. This is not a how to create a layout quickly tutorial, but one that I hope will make you understand the layout system in detail, so you will know what to look for and how to think about creating more complex layouts once you are on your own again. So in this video, we will have a very close look at how the core three components of UI layouts actually work: layout groups, layout elements, and content size fitters. I'll go through 4 examples, starting with a vertical layout group and explaining the core concepts while creating a simple info window. In the next step, we will look at a layout that uses horizontal as well as vertical layout groups, and you will learn what to keep in mind when working with interlocking layouts. This is also about common pitfalls and problem areas, and how to troubleshoot them. Chapter 3 is about grid layouts, which use many of the systems of vertical and horizontal systems with a bit of a tweak. And in Chapter 4, I'll give an example on how to create flexible layouts that aren't bound to static pixel values, but percentages and relationships instead. They are a great starting point to work with when creating complex layouts later on. I also released a PDF guide on this topic over on my Itch and Ko-fi pages. The link is in the pinned comment. It comes with my project file, a neat cheat sheet for the layout groups, and all the infos from this tutorial in a way that's maybe a bit easier to look up and refer to. Let's rewind time a bit and start with the initial rough draft of the info window. I prepared a container for all the elements, added 2 simple images to it, 2 text boxes, and an image with a text label acting as a button. The texts are already styled for their intended purposes, so that there's a clear hierarchy of information available. The first step to give it a bit of structure is to add a layout group to it. You can choose from horizontal, which initially grows into the right direction, as well as vertical for the down direction. I'm going for a vertical look here. Instantly, the child elements get organized vertically by their child index order. You can test that by switching the places of 2 elements. The second thing you will notice is that the button is currently overlapping heavily with the descriptive text of the window. This will of course be fixed down the line, but we will tackle this system one thing after the other, so we will have to bear with this for the time being. Let's have a look at the layout group. It's one of the very few components I typically set up from the bottom to the top, instead of going top to bottom in the settings. This is how it looks when you first attach it. And in case you don't see the left, right, top, bottom paddings, you can fold out the paddings by clicking on the arrow next to it. This is typically where people start randomly clicking on things to make the groups behave as intended, so we will have a closer look at what these settings actually do, starting at the bottom. Child force expand is enabled by default, so it stands to reason it's important. But what does it do? As it stands, our info window is still 100 pixel by 100 pixel in size, the default size for every new game object on a canvas. That's obviously not the size we need. We can see how child elements overflow this box after all. Let's drag its size to a value that gives each object space inside of it, and that's already when you see width and height force expand in action. I have to drag quite a bit to manage to get the button to not overlap with the text box, and all the other elements are suddenly far away from each other. That can't be right, right? Let me just attach a small visualization helper to the layout group. Its only reason for existence is so I don't have to draw a lot of indicator and helper lines in post-production, and it will make it a lot easier to understand what's going on. Yay for helper lines! You might already get an idea of what child force expand does here. It takes the number of child elements and divides up the height of the container by that number to give each equal amounts of space. In short, it spaces them out. Not every element needs all that space, but our layout group doesn't know that yet, and just goes by the size, in this case height, of the child elements. This is also an excellent moment to show what child alignment does. By default, it is set to upper left, and as you can see, all child elements are oriented so that their upper left corner is in the upper left corner of their designated space. Click through the drop-down to see how the location will change based on the settings you choose. These are especially helpful for more complex UI hierarchies and layouts, but top left is a good initial setting, so I'll keep mine for that going forward. When you drag the height down a bit, you can see how those areas between the pink lines shrink, and at some points the button will overlap the text box again. So why is that? Let's have a look at the child elements for this, starting with the header. It's a simple image component I tinted in red. Its width and height are set to 100, as is normal for a default UI element. We can click on the bar down here and get a preview of the image we set up in the component. Obviously, it is currently empty and tells us the image size is 0 by 0. Here's where it gets interesting. Click on the drop-down and choose Layout Properties instead. This is an incredibly useful info window we will look at a lot going forward, because this tells us quite well what's going on with our child elements and layout group component. As expected, all the values are set to 0 here as well, since we have no image setup. It's basically only 100 pixels inside the scene view, because the image spans the whole width and height of the game object it is attached to. I'll switch over to the main image now, and the preview already shows the default image I set up inside the component. A simple 100 pixel by 100 pixel graphic. This one is actually the same size as the game object it sits on, and when I switch to the layout properties, you can see minimum set to 0, while preferred is set to 100. I'll go more into why this matters in a few minutes. The headline has layout properties as well. Here it shows a preferred height of roughly 45 pixels and a preferred width of about 300. I'm rounding up a bit generously here for simplicity's sake. However, the values we see inside the rect transforms width and height look very different. 250 by 50 pixels is the default text box size I set up for this project, and since I haven't made any changes yet, it still shows those numbers. So what happens if I change those values to the ones I can see in the properties? Well, it's the exact size the text box needs to be to contain the text in one line. Neat! That's for a simple headline though. What about the descriptive text? You can see that the preferred width is a rather ridiculous number, but then again, the text I set up for this box is quite long. Let's test if this is the actual width the text box would need to contain all of it in just one line. Yep, sure does. That's not what I need, however, so let's go back. Instead, I have a preferred height. What do you think will happen here if I use this number for the height of the box? A. The text box will expand to fit all lines of the text while keeping the width at 250 pixels. Or B. There will still be some fiddling with values afterwards to make it all fit. If you picked A, you're on your way to understand layouts much better going forward. The last entry is the button, which again has a default graphic setup. We get preferred width and height of 100 again, but images are typically fine with being squashed and stretched, so of course it fills the 250 by 50 pixel space very well. Now let's go back to the container with the vertical layout group attached. We can now change the height again, but this time our button will not overlap the text box. Check the layout properties here. By default, the layout group will slice the height, or width, of the container into X amounts of similarly sized areas, one for each child object. It takes the actual size of each element into account when doing so, but tries to still expand each area equally in case there is enough space for each child already. But once we change the sizes, like setting the text box to a preferred height, so that there is no text overflowing the box, it has to work with very different sized elements. Because of this, the layout group will still try to accommodate them, but with a focus on their actual size in relation to each other. You can test this easily by deselecting the height of a vertical layout group, or the width when working with a horizontal one. Suddenly, everything snaps back together with no space between each child element, defaulting to the size each child element is set to. If I drag the height down to where the button ends, we can see the number is roughly equal to the preferred height of the container, a number that is calculated based on the preferred height of each child element. So we have a basic layout now, and even though Child Force Expand has its use cases, most of the time I actually prefer to leave this toggled off, as in keeping width for vertical layout groups and toggling off height, and vice versa for horizontal ones. It gives me more control over the actual layout, which is important to me, and you'll see another benefit to this in a moment. Here's where we can have a look at padding and spacing too. Padding is the area that is left empty around each child entry. It's visualized in blue here. Spacing, on the other hand, is the space between each child. This is yellow. You can see how changing those values changes the preferred height and width of the container as well. If this were a never-changing window that always had the same amount of text and the same size of image, this would be all I'd need, but that's rarely the case, is it? One of the most common use cases for layout groups is to have a box size itself based on its content with more flexibility. After all, we can drag the width of our box, and all the child elements keep their set width instead of filling the available space. Let's see what the layout group offers next. The next row is Use Child Scale, and if you only ever use child elements with a scale of 1, you will never have to toggle these on. Generally, I highly advise to only ever keep UI scaling of any element to 1, as going beyond the number could lead to lots and lots of headaches about elements not behaving as you expect them to. I still remember the struggles I ran into when I just got started with UI and didn't pay attention to this rule. But let's see it in action to understand it. I'll change the main image scale to 2. As you can see, it now overlaps everything in its surrounding area, even overflowing the main container a fair bit, and the preferred width and height still state themselves as 100. If this is absolutely what you need, you'll have to toggle on Use Child Scale. You'll have to ignore my helper lines here for a moment, as I haven't optimized them for the edge case, but you can see the new arrangement of the child elements when checking each of them. The overscaled main image now fits neatly into a row, with the header right on top of it and the headline right below it. Useful, but again, it's always better to work with a scale of 1. I'll undo the scaling now, and you can see everything snapping back again, and continue to ignore these 2 boxes going forward, please. Control child size is what we are really looking for, since we want to change the width and height of our infos, and the contents should react to those changes, right? So let's check width and height, and, well, apparently this removes the header from our group. Pause the video for a moment and have a guess as to why that might have happened. If you're stuck, I'll give a hint in a few seconds. Stumped? Alright, I'll do it again, and this time check the change in the layout properties. We suddenly lost exactly 100 pixels in height. Let's switch over to the lost header, which should still be visible after all, since it's enabled in the hierarchy, right? Well, yes and no. It would be visible if the layout group hadn't reduced its size to 0, which it did, because it looked at each child element of the container, read the preferred width and height, and set it to those values as soon as I clicked the Control Child Size toggle. This is what controlling the child size means. You can see we can't make any changes to those 2 fields anymore up here, because these are now controlled by the layout group. Every other child element has to be set to its preferred height as well, overriding the roughly rounded adjustments I made previously. You can see this in action when you now try to change the size of the info window container. I can make it wider and the text will correctly fill the available space. That's what most of us want from these kinds of layout groups after all, but how can we make sure we will still get the header? Well, there are 2 solutions. The first one is one you'll surely have thought about as well. Setting the image to an actual image source with a set width and height. Great first step. I'll use my trusty mini pixel graphic for this. I explain in more detail why I use this in my recent How to Set Up a Project as a Template video, but in essence it comes down to the fact that it's incredibly tiny and works well enough for lots of UI use cases. But the thing is, this graphic measures just 2 pixels. The header now shows up again as intended. I can see it in game view at the top when I zoom far into the layout. But it is obviously still not the size I actually want. It's also a good example here, since oftentimes the graphics you are working with will not fit the intended space perfectly either. For situations like this, we need to utilize the layout element. The layout properties already informed us about being able to overwrite the shown values after all, so let's give it a test. Ignore layout is handy, but not what we need right now. I'll show a good use case in a few minutes. Much more interesting are the minimum and preferred values. Minimum basically means I can't be set to a lower number in width or height than this, while preferred means I really want to be this value and will tell everybody that's what they should treat my size as. Let's give it a minimum height of 50 and see what happens. The header is back, and its value is now set to 50, even though we could not, change the value inside the rect transform. Basically, the layout element told the vertical group component its minimum size, and the group component accommodated it. We can see this change in general preferred size happening in the layout element as well. And suddenly we can see why the minimum width and minimum height of our layout group are important as well. Let's resize the container down to almost 0 in width and height and see what happens. Everything tries to shrink down as far as possible. Let me just set the overflow method of the Text Mesh Pro boxes to truncate for this to make it even more visible. Truncate cuts off all the text that has not enough space to be displayed. The only thing left to see is the button label, since we haven't given that any thought yet, and the 50 pixel high header image. When I increase the size, all other elements will show up again and expand until they are again sized based on their preferred size. All that is but the header image, which will just stay at 50 pixels. Generally, the layout group will look for a preferred size, but if it doesn't find one, it will take the minimum size. If that's not available either, like with the header previously, it will default to 0. Let's set the minimum size to 50 and the preferred height to 100 to see it in action. It instantly increases its size to 100 since there is enough space available. But see what happens to it when I shrink down the size of the container again. The scaling will stop once it reaches the minimum size and expand until it fits the preferred size. If I increase the height of the container again, and this time also toggle on the child force expand height, it will even go over that preferred size if there is enough space to allow for it. Basically, the parent tells the child to grow, and it does. Still, once the height decreases, it stops again at the minimum height. A preferred height of 100 pixels is a bit much, however, and for intentionality's sake, I'd really like to keep the header graphics consistent across elements. Because of that, I will set the minimum size to 20 and do the same for the preferred one as well, so that no matter how I decide to set up the layout group going forward, this header will always measure 20 pixels in height. We can use the same principle for the button, which label sits rather unceremoniously in thin air when the container is too small to display everything. First, I want the label to always be centered in the button itself. To do so, I have to change the anchors and have the element stretched to full size in every direction. Hold Shift and Alt, click on the anchoring menu, and pick the one in the lower right corner for this. More about anchors in my guide or video on the topic, although the guide goes into much more detail. Okay, have a guess. I always want the button to be 50 pixel high and not scale over that value. How do you think that can be done? Pause for a moment and give it a test. Alright, let's see if we came to the same conclusion. I'll attach a layout element and set its minimum height and preferred height to 50. The button now behaves as expected. This is where you will have to make a decision about how responsive your window is supposed to be. And I don't think you'll be surprised that there are multiple different ways to tackle this. As you can see, the minimum width and height are far from the preferred sizes of our container, and whenever you come across a value of 0, there's a chance of it disappearing into the greater layout of your project. The first idea for a solution would be to attach a layout element to every child element. Could be alright, could also be super bothersome, depending on the layout of your container. Keep this in mind, however, since doing something manually typically leads to more work, but also a cleaner solution in the realm of UI. Another solution is to use a content size fitter. If you ever attached one of them to a child object of a layout group, you will have seen a warning, and we'll come to that at a later point, but I prefer showing the right way of tackling something at first. It's a simple component that asks you how you want a UI element to be sized. Unconstrained means it stays freeform and you can put in numbers for width and height as you wish inside the rect transform. Preferred takes the values it finds in the layout properties box and works with those. You typically pick either one of them, rarely both, without an extra step before doing so. For example, I'll take the vertical fit to preferred size, which shrinks down the content box to the preferred height. Now, if I also set horizontal to preferred, will I get nonsense? But what is very obvious at this point is that I can't change the layout and sizes at all anymore. Neither for the main content layout, nor for any of its children. Math has taken over. Oh no. So if I actually like this inability to mess with any values here, and there are good reasons for doing so, as it makes sure everything is sized as it's needed, even if the contents change and you won't accidentally mess up your container, I need to take one more step. How do you think can the width be controlled when we can't access the rect transform? Have a guess, we did this before. Alright, so let's attach a layout element to the container itself. Set its minimum width to something more or less reasonable and the preferred width to something a little more generous. We can now position the box wherever we want it to, but won't run into any scenarios of accidentally changing its size anymore. Our container's width is also much more reasonable now. At this point, you will only see differences the child alignment makes if you toggle off the child force expand, by the way. It's been a while since the video started, so let's repeat some of these concepts. Use child force expand to have child elements stretch in either the width or height of the layout group. It will try to slice the available space to roughly same-sized blocks to position children in, and won't change the actual width or height of each child element. If you toggle it off, it will just list each child element under or next to one another based on the respective height or width of each child object. Which one it is depends on if you are working with a horizontal or vertical layout group. Use child scale if you want or absolutely must break the best practice rule of keeping all UI elements at a scale of 1. Again, please just don't do this. Find a different way to keep child element scales at 1. Control child width will take away your ability to change the actual width and height values of your child objects inside their rect transforms, and the layout group will forcefully expand them to fit the space available. The numbers that will be used depend on the preferred width or height of the object, as stated in the layout properties, then the minimum width or height of the element. If both are not available, the number to calculate its width and height will be 0. You can change the minimum and preferred values by attaching a layout element to the child object and setting the values there. If child force expand is toggled on, the layout group will go over their preferred size if enough space is available. If child force expand is toggled off, it will stop at the preferred size for each element, even if the container the layout group sits on is wider or taller than needed. An additional tip for the content size fitter is that it always grows from the location of the pivot. Here, have a look. The pivot is in the center of the container. See what happens when I go to the description text and just copy-paste it once or twice more to make the text longer. We set the container's width in stone by adding the values to the layout element, but it can grow in the top and bottom direction. Since the pivot is located in the center, it will grow into both directions equally. That's typically not what we'd expect and can easily lead to unintended side effects like suddenly cutting off elements below or above the viewport. We can, however, set it to only grow in one direction, up or down. To do so, we need to change the pivot's location by either dragging it to the top or bottom line of the container. It will snap when it's in range. Or alternatively, by setting the Y value of the pivot to 0 for the bottom and 1 for the top. In case of a horizontal group, you change the X value instead. Let's see both versions in action by again giving the description box more content. See how the top and bottom stay rooted in place while the content shrinks and grows? That is ultra handy. And by the way, if working with pivots and anchors is new to you, I have a guide covering both in lots of detail. Before switching the layout over to a horizontal one and giving a little more advanced layouts a look, which you will want to watch, trust me, let's finish the design of this info window. It's currently looking a little lost in space, as it is after all. First, how would you go about creating a background for this box? Because it would need to be resized correctly as well, and if we just place this info box on any other image we use as a background, that won't be happening. We could also add both to a parent object, resize that one, but again, it would only resize the background, not the info window part. One solution is incredibly simple, and you might have already had an idea based on a component we used previously. I'll create a new child element here and call it background. As backgrounds do, it should be located below all the other child elements, and initially, of course, the height will be 0, since this is basically just an empty container. We can see this because the layout properties box is missing. The background container gets a child image object. Predictably, it sits at the top with a size of 100 by 100, since that's what default UI elements do. We wanted to fill all the available space the parent container offers, which is still 0 at this point. This we can do by changing the way the anchors are positioned. Shift-Alt-click on this icon and pick the option in the lower right corner again, just like we did to position the label for the button previously. It will be invisible because its parent container has a height of 0, and that's okay. Switch back to the background container and add a layout element. This time we don't care about minimum or preferred width and height. Instead, we need the ignore layout toggle. Once active, all the values inside the rect transform are available to be changed again. Just like with the child image object, we want our background to fill all the space of the parent object, which is our info window itself. Alt-Shift-Click on the anchoring menu, pick the down right one once again. Yay, we have a background! This is now a good moment to set up some graphics for it and the main image, so that the layout looks a bit more fun to look at. Notice how the preferred size of the main image changes when I drag in a different image. One thing that irks me a bit about responsive layouts like this is the trade-off needed when it comes to working with images here, at least at first. Images get stretched and squashed to fill the size of the game object they are attached to, which typically means that the end result doesn't always look as I might have expected or even wanted it. I really want to keep the aspect ratio of images I use, but as you can see, that will lead to empty space to the sides of it, since the system tries to figure out how to resize it in a way to fill the most of the available space. You can solve this problem by working with masks, but this walkthrough already has enough topics to cover and remember, so masks will come in a future tutorial. I will also change the font color from white to a dark gray here, so we keep a good contrast between it and the background. But a good layout always affords its elements breathing room, so at this point in the design process, I'll add padding and spacing once more. If you need more space between specific elements, work with empty game objects. They are always called spacer in my layouts, so I know what they do. There will be the spacing values added around them as you specified in the layout group, but if you need more, you can always add another layout element and resize the object to fit your needs. At this point, the helper lines are rather distracting, and I hope the point has come across by now, so I'll remove the component. The reason why we added the background image, not to the background container itself, is that we might want to add more decoration. As long as we keep them contained inside the background container and work with the correct anchoring settings, customizing the look beyond just a simple box is no problem at all. If you need elements to overlap your layout, just repeat the same steps as you did for the background, but instead of moving it to the bottom of the hierarchy, move it to the top. For overlapping elements, always check if their raycast targets are enabled or disabled. In case you expect to be able to click something behind a decoration, you'll have to set that to off, so clicks won't get caught by decoration instead of interactive elements. And is anybody else constantly frustrated how bottom is actually at the top and vice versa? Is it just me? So these are the settings for each of the parent and child elements in case you want to copy or check any of them. If you enjoyed the tutorial so far and learned something new, I'd really appreciate a like and subscribe. If you would like to support the creation of more videos like this, you can find my written guides in my Itch and Ko-fi store. I think you might enjoy those, seeing as you managed to get this far in this video already. Alright, onwards to the second chapter of this video. What if your layouts get more complex than just this admittedly simple one? For this, I'll duplicate the layout and switch it over to using a horizontal layout instead. Horizontal is as easy as vertical is, but this time we are going to use more than just one layout group. This will take a few tweaks, and I'll go over them one by one. First, the vertical group component is removed, and the content size fitter and layout element get deactivated for now. They will get reactivated once everything looks correct again. I'll attach a horizontal layout this time and mirror the settings I had on the vertical one, so this time everything gets expanded in height but not in width. I want everything to stick together as closely as possible, not to be spread out after all. My height dropped to 0 for the container, so I'll give it some value that sounds alright at first glance. As expected, the contents are a mess, so let's go through them from the top to bottom. No changes are needed for the background, as it already ignores everything going around it and just fills the available space. Thanks for being so uncomplicated, background. Header has a minimum height, but for horizontal, we care about width instead. The main image doesn't play nice, so it gets a layout element attached to it as well, making sure it doesn't fall below a certain value. I'll deactivate the spacers for now, because these are polishing steps better left to the end of the workflow. Instead, I'll jump to the button and make sure that's some actually clickable value where the label is still readable as well. That leaves me with the two text boxes, and quite frankly, this looks turbo ugly from a designer standpoint. The headline is barely readable, and even if we increase the space allowed for it, we are left with a lot of empty space, which makes the whole layout look unintentionally empty. If you're working with a language that is read top to bottom, I do believe it could look really cool, but this is not working for a left to right or right to left kind of language. I rather liked the vertical structure we had before, as it's more akin to what we are used to when reading texts. I'll select both elements and create a new parent object for them. Just in case this is actually an assets doing that I have this entry in my dropdown, you can just create a new child object to the info window and drag and drop both elements into it, of course. Naturally, it defaults to a width of 0. Our layout group is set up so it expands only the height this time, and since we do not have a layout property, because we are lacking a layout element, layout group, or something that is considered a graphics component like TextMesh Pro or images, the layout group thinks this new container is happy with a width value of 0. We could fix this with a layout element, but I want the infos to be stacked on top of each other. That's the job of a vertical layout group again. Just like with the first vertical layout group, I'll set the controlling of the child sizes to true for both width and height, and tell it to force expand the children's width. This makes sure the text box will be able to grow with the amount of text in our boxes. Here are some visuals again to see what's happening. But wait. If we copy-paste the example text a few times, the main box does not grow or shrink anymore. Why is that? Well, before we tackle this, we need to check something else. The headline is also suddenly gone. If you're following along and it is still visible, you did not set its overflow method to truncate, which will cut off all the text that does not fit into the provided space of the text box. Here is an easy fix. Attach a layout group and give it a preferred size. Chances are great you can just keep the value it defaults to. Alright, this fixed, let's go back to the main horizontal container. We toggled off the layout element and content size fitter, remember? Because of this, our info window doesn't know it's supposed to resize itself based on its contents anymore. Ignore the layout element for now, and before activating the content size fitter again, have a look at the layout properties and guess what will happen if you enable it again. Yep, it will grow to the preferred width. And where does that come from? The vertical layout group inside of it, of course. So we need to override this child group's preferred width, or it will tell the parent that it really wants those almost 3000 pixels for itself. By now you should know how to do this. Add another layout element and give it a preferred width you consider wide enough. you can drag the value in either direction and see what it looks like too. At this point, the main container is ready to resize itself again in a way that looks much more intentional. Alright, time to fine-tune a few things. First, the layout looks rather squished into the general shape again. Back on the parent container, I'll add back some padding and spacing for everything. This is fine alright, but I'm not yet quite happy with how the vertical text is aligned inside the box. The way it looks, everything feels a bit top-heavy. When working with layout design, keep in mind in which location on the screen this is being displayed. A top-heavy element below the center line will have the visual impact of a sudden extremely heavy brick, which might make your whole layout feel unbalanced. If you are going to position it below the line, try to keep space at the top instead, while if you position it above the center line, keeping empty space at the bottom will feel alright. The biggest exception to this rule is a dialog box. Your players will expect to see the starting line of the dialog always in the same location, so working with a top-heavy layout is actually good practice here. So remember child alignments? Our text box container is stretched higher than its preferred size, which means the child elements have a bit of space to be aligned differently, in contrast to our initial vertical layout group container. For this layout, I actually quite prefer having a lower left child alignment. The space at the top feels more natural than at the bottom for this location, giving it more visual weight when placed below the center line of the viewport. At this point, you might still be waiting for me to attach the content size fitter to the layout group, and you would wait in vain. But let's have a look at what happens if you do attach one. The component will warn you that it should not be attached to a child object of a layout group, because the layout group wants to set the size of the child. By giving it a content size fitter, it and the layout group will fight over who gets to set the size, leading to internal conflicts. If you ever needed to look up or manually write a line of code about rebuilding the UI on Activate, this has most likely been the culprit. So instead of attaching it, we will trust that the infos we set up inside the layout element and the automation happening inside the main parent layout group will make sure our elements are sized correctly. The last element to enable, if you want to, is the parent object's layout element. Just make sure to give it values at or slightly above the preferred width, but this time this feels already good enough as is, and I'd consider removing it altogether from the object. Just like with the initial vertical info window, you can experiment with changing the horizontal fit to on-constraint, which will enable you to make the box wider or slimmer. Spaces don't feel as important this time around, and I will remove them from the layout as well. Alright, if my text editor's calculations are correct, you watched this for almost 30 minutes at this point. If you learned something new, if you enjoyed what you saw and haven't done so already, please give this video a like and subscribe before we are heading to the home stretch. Onwards to chapter 3. Let's learn to appreciate the grid layout group, because I feel like it gets some undue flack from time to time. I'm starting with just an empty game object and attach a grid layout group component to it. On first sight, it already looks quite a bit different to the vertical and horizontal one we tackled before, doesn't it? Let's add 5 simple child objects with default image components to it. Remember, these do not have a source image setup, so their layout properties come up as 0 across the board. I'm explaining in my recent How to Set Up a Project video how you can change this default behavior and start with a real image already prepared in it. Since the images are the same size as the parent object, they will just get stacked on top of another. Let's change the parent size and see what happens. It takes the width of the parent object, divides it by the actual size of the child elements, and fills each row with as many child elements as it can before starting a new row, right? Good guess, but that's actually not quite what happens. Since everything defaults to 100 pixels in width and height, it might look that way. But if we look closer at a rect transform of a child element, we can see that we actually can't change any of the upper values here. That is because those are being controlled by the layout group, and this time you can't disable that. It works like a combination of control child size and child force expand, found in the 2 other layout groups, just that it's toggled on by default. The only thing for you to control is the size of each child element by changing the values for cell size, which again defaults to 100. So really, to determine the amounts of rows and columns, It looks only at the amounts of children the layout group has to manage, the cell size set up inside of it, and any kind of padding and spacing. It determines the starting corner and axis based on the first two drop-down settings found here. Child alignment works just like before at first glance, but it's a bit more general this time, as there are no areas in which the children get aligned. Instead, they are aligned based on the object the grid layout is set on, which can get a bit confusing, so just like with the previous two layout groups, I will ignore it until the very end. A lot more interesting, however, is the constraint dropdown. Here you can set if you want the layout to figure itself out, which is something my perfectionist side won't allow. Give it a fixed amount of columns or a fixed amount of rows it can fill. These two are most likely what you are looking for when creating a grid of anything. Just like before, we can set up a background image by adding another container for the background, to which we add an image component. Make both stretch in every direction, then add a layout component to the background container and set it to ignore the layout. Now that I wrote that sentence, that sounds strange, but it's the way to go. By tweaking the padding and spacing values, you can lay out your grid as you need. Making sure it resizes in accordance to what you set up inside the constraints and cell size boxes, have a guess at what you will have to add next. We are at the top of the hierarchy. We have a layout group. We see the layout properties. We can utilize a content size filter. By setting it to preferred size on both axes, our window resizes itself to its optimal size. Make sure to set the pivot in the opposite side you want to grow this container, just like we did for the vertical groups. This will already do nicely for most inventory systems, but what if you want to go in the direction of a bento menu? That's a term used to refer to those card-based menus, where there can be more than just one card to click in any given row or column. You can, of course, combine layout groups. We already did so for the horizontal one after all. Here I am creating an ultra basic vertical layout group container with two child images that also get button components attached to them, purely to show some interactivity. I can set this kind of element as a child object of the grid layout group without issue. Just make sure to not attach any kind of content size filter to it, or you will run into problems again. You will get an especially nice effect if you set the spacing of the new group's elements to the same value as the spacing of the grid layout group. In contrast to the layout groups before, a grid layout doesn't have a setting to maximize its cell sizes based on the contents you set up inside. Let's see this in action by copying the initial vertical layout group container as a child element into the grid layout group. It squashes and stretches based on the values it finds on the vertical layout group, but we can see that the content size filter gets a warning message. That's our cue to remove it and let the grid layout dictate the size based on the vertical group's preferred width and height. These we can set in the layout element like before, but due to the cell size setting of the grid menu, they will get ignored. In these cases, it's a good practice to manually set the cell sizes of the grid layout to the preferred size of the complex child element. Whenever you get strange situations where what you see doesn't make sense to what you expect, always have a look at the layout properties box of the parent, but also of the children. That's the easiest way to figure out where your layout went wrong. And a bonus chapter for those of you still watching, and thank you so much for doing so. Apropos layout properties, we glossed over one setting entirely: flexible width and height. We previously always set specific pixel values to our elements, but there are obviously always cases in which we want the children to size themselves more flexible numbers, like having a tab menu system, where the tabs on the side always take up 30% of the space of the container, while the remaining 70% are left for whatever the tabs cycle through. You would be working with flexible width and height here. First, let's have a new container to see what's going on. Mine gets two default images attached. They have a size of 0, as you remember, but for this, it really doesn't matter and is more of a help to visualize the process. I add a horizontal layout group to the container, ignore the overflowing elements on the side, and we will have a look at the layout properties straight away. We see the values are at 200 for width and 100 for height. No surprises here, the two boxes are each 100 pixels in both directions. However, we also see that the flexible width and height have been enabled with width being 2 and height being 1. Again, that does make sense. We have two elements of equal size here. Let's change the size of the container and see what happens. When I change the height, there is no perceivable change, but from our first vertical layout group and the pink lines, I hope you remember that the area now opening up is half the width of the container and the full height of it too. For this use case, we actually want to keep the expansion in both directions and also toggle on controlling of the child sizes as well. The container is now equally divided into two areas. Here's where it gets interesting. Attach a layout group to both child elements, enable flexible width, and see what's happening. Well, that's not much at this stage. Pick either one of them and increase the value to 2. Your chosen child element is now always taking up twice the amount of space as the other component. Or, explained a little differently, check back with the horizontal layout group. The flexible width down here now counts up to 3. Think of those as parts of a whole. You can go as high as it feels reasonable for your use case. For example, one area set to 10, while the other is set to 90, will give you a nice round percentage value. The only caveat is that you can't really change the individual flexible height of each child element in a horizontal layout group like that. Vice versa for width of elements in a vertical layout group. Child force expand will always stretch to the full height, even if you tell it that each entry should only be half or a third of the content's height. In these cases, you would have to go back and work with preferred height and untick the force expand on width. As you can see in that case, flexible height will be disabled. Ducklings Batman, this was a walkthrough, wasn't it? But layout groups are a core and essential topic that deserve the full use of the magnifying glass. Are there still questions left? Anything you were surprised about or expected to see but didn't? Please let me know. I sincerely hope this was useful to you. I honestly hadn't expected this to turn out with this kind of runtime. And again, thank you so much for watching. I love going deep into topics like this, so if you need something covered, feel free to let me know. And in case you want to support what I do with more than a view and a like, which I do very much appreciate, consider having a look at my guides and services over on Itch and Ko-fi. Have a great week!